So through this video, I am explaining question number 7 from the back questions of aldehydes and ketones. Question number 7 says, which compounds from the following will undergo aldol condensation, which will undergo Cannizzaro reaction, and which will not undergo any one of them. Now for this we need to know the criteria for aldol condensation to occur and for Cannizzaro reaction to occur. Now for aldol condensation, I've already explained through one of the videos that for aldol condensation at least one alpha hydrogen atom should be there, and for Cannizzaro reaction no alpha hydrogen atom should be there. Now what is to be noted over here is that aldol condensation reaction can be given by both aldehydes as well as ketones. Both aldehydes and ketones undergo this reaction, but the condition being that both of them are possessing at least one hydrogen atom at the alpha position. There can be more than one hydrogen atoms also, but at least one is needed. For Cannizzaro reaction to occur, first of all, Cannizzaro is given only by aldehydes and it is not given by ketones. It is not given by ketones. What is the condition for Cannizzaro reaction to occur? That no alpha hydrogen atom should be present. That means no hydrogen atom should be present at the alpha position. Such aldehydes undergo Cannizzaro reaction which do not possess any hydrogen atom at the alpha position. Okay, let us discuss one by one. The first compound, 2-methylpentenyl. Now all of you can draw the structure of 2-methylpentenyl. If this is your functional group, the carbon atom which is next to the functional group is your alpha carbon atom. It is your alpha position. Now at this alpha position I have one hydrogen atom present. Because I have one hydrogen atom present, so it is satisfying the condition for aldol condensation to occur. So we say that this particular compound will undergo aldol condensation. Your next compound is cyclohexanone. All of you can draw the structure of cyclohexanone. Now C double bond O group. This is my functional group. The position which is next, either on this side or on this side, which is next to the functional group, is called as the alpha position. Both these alpha positions are equivalent. Now if I consider this alpha position for example, then this carbon atom is already having two bonds around it. So it must be having two hydrogens also in order to satisfy its valency. So at the alpha position I have two hydrogen atoms present. So this compound again will undergo aldol condensation. Now a third compound is 1-phenylpropanone. All of us know that propanone is drawn as CH3COCH3. That means you get C double bond O group in the middle between these two carbon atoms. But over here I am drawing this at the terminal positions, right? I am drawing this C double bond O group at the terminal position in this 3 carbon chain. Why I am doing that? Because it says 1-phenyl and I have to give the first position to my functional group. So at this first position I have the phenyl ring as my substituent. This is my second position and this becomes my third position. Okay, now if this is my functional group, then both the positions which are next to the functional groups become my alpha positions. So this is also alpha and this is also alpha. This particular alpha position is having 4 bonds already, so it does not possess any hydrogen atom, while this alpha position has 2 hydrogen atoms attached, right? So this can again undergo aldol condensation. Phenol acetaldehyde. Now what is acetaldehyde? Acetaldehyde is the common name for ethanol. if CH3CHO is acetaldehyde, then what will be phenyl acetaldehyde? Phenyl acetaldehyde means that one of the hydrogen atoms from here has been replaced by the phenyl ring. So it becomes CH2 here, and you attached one phenyl ring in place of the third hydrogen atom. So again, if this is the functional group, the position which is next to the functional group becomes the alpha position. It already has two hydrogen atoms, so it will again undergo aldol condensation. Methanol. This is the functional group and there is only one. The positions are referred to as the carbon atoms, right? So this particular compound has only one carbon atom. There is no other carbon position next to this carbon atom. So there is no alpha position existing in methanol. There is no alpha position because the position is just one, which is the functional group itself, right? When there is no alpha position, there is no alpha hydrogen, obviously. So those aldehydes which have no alpha hydrogen atoms, they undergo Cannizzaro. Fine. Now benzaldehyde. This is your functional group. The position next to it is the alpha position. Now this particular aldehyde has the alpha position, but the alpha position does not have any hydrogen atom because already there are 4 bonds around this particular carbon atom. So alpha position is there, but alpha hydrogen is not there in this compound. So this will again undergo Cannizzaro. Cannizzaro is the reaction which is given by those aldehydes which have no alpha hydrogen. 2,2-dimethyl butanol. All of you can draw the structure. This is the functional group. The position which is next to the functional group is the alpha position. As you can see very clearly that around this carbon atom there are already 4 bonds present. So there is no space for hydrogen atom. That means this does not possess any alpha hydrogen atom. So again it will undergo Cannizzaro reaction. Fine. Now the next compound is Benzophenone. This is your benzophenone, 2 phenyl rings joined by a C double bond O, ketonic group. Now from the one itself I know that this is a ketone, right? Now Cannizzaro reaction is not given by ketones. So the only option left with me is aldol, right? And aldol is given by those aldehydes and ketones which possess alpha hydrogen atoms. So if this is my functional group, then this is alpha and this is also alpha. Both of them are alpha positions, but none of them have alpha hydrogen atom. So this can neither undergo Cannizzaro because it is a ketone, and Cannizzaro is given only by aldehydes, nor it can undergo aldol because it does not possess any alpha hydrogen atoms. So it will not undergo any one of these reactions. Alcohol. Obviously, when we were talking about aldol condensation and Cannizzaro reaction, we did not talk about alcohol anywhere because these reactions are given only by aldehydes or ketones, right? So this will not undergo any, none.